This is a lecture about modulo. Here is a simple equation. 3 divided by 2 equals 1 with a remainder of 1. But what if I only want to know the remainder, not the quotient? That is what we are going to find out. Let's get right into an example. Modulo 5. What does that even mean? It means that as you begin counting numbers and as the counter approaches 5, the counter restarts from 0. In this case, the counter would count 1, 2, 3, 4, and instead of 5, it would go back to 0, 1, 2, 3, and so on and so forth. Now, here's an expression, 3 mod 2. What you have to do is simply count 3, but with a modulo 2 system. Usually, we would count 3 as 1, 2, 3. With the modulo 2 system, however, the counter would reset at 2, so we should count it as 1, 0, 1. The answer to 3 mod 2 is 1, and it is not different from how we get the value of remainders. Now there are two equations, and it is already noticeable that 3 and 33 have the same remainder of 1 in modulo 2. Therefore, we can state that 33 is a modulo 2 residue of 3, or 5, or 9, or even vice versa. The point is that there are many values of the same residue. There is a unique sign used for modulo. This sign tells us that the two numbers on their left and right sides have the same residue modulo. In a more concise statement, 3 and 33 are congruent modulo 2. And there's an easy way to verify whether the two numbers are congruent regardless of how big they are. If the subtraction of the two numbers divided by m, or modulo base number, is an integer, then the two numbers are congruent modulo m. Let's apply the numbers we have here. 3 minus 33 is negative 30, and when it is divided by 2, it equals negative 15, which is an integer. Therefore, we can conclude that they are congruent modulo 2, and it remains consistent with what we know about congruence. There are some arithmetic rules that you have to keep in mind. If a and c are congruent modulo m, and so for b and d, then the sum of a and b and the sum of c and d are congruent modulo m. When you think about it, it is pretty reasonable because a and c have the same remainder, and b and d also have the same remainder. Therefore, the remainder of a plus b and c plus d will be equal. Given the same condition, for the same reason, the subtraction of a and b and that of c and d are congruent modulo m, and also the same for multiplication. The entire concept of modulo is not often used in mathematics, but rather in coding. Instead of mod, programming languages use the percentage symbol for modulo. For example, 385% 21 means 385 mod 21, and the output would be 7. Here's a pseudocode example. If there's an integer time hour and it equals 7, and print a message according to the code with time hour mod 24, then the output would be the time is 7 o'clock. Special thanks to SlidesGo for the template of this presentation. Thank you for listening.